Antigens present over the surface of RBC are the key factors in determination of blood group of an individual. For instance, antigen A and B present over the surface of RBC imply that the blood group of that individual according to ABO blood grouping is AB. Now, another antigen which is important besides these AB antigen is H antigen or H substance, which is present over the surface of RBC2. Let us consider these black lines as H antigen or H substance. Now, what these H antigen or H substance are, these are the precursors for A or B, both the antigens. H antigen or H substrate act as the substrate for A or B antigen. Here, this H antigen or H substance transforms into A or B antigen or both, depending upon the blood type of individual. Therefore, H antigen is extremely necessary for representation of A and B antigen both. What happens in Bombay blood group is these H antigens are completely absent. So, RBC of an individual with Bombay blood group will have no antigen over its surface. It would lack all the antigens, including the most important H antigen. Bombay blood group is failure to inherit the H gene from either parent or inheriting recessive alleles from both the parents. That is explained as follows: a male and a female, both having heterozygous capital H and small h genotype, they will segregate into alleles capital H and small h, capital H, small h both. Now, a combination of these recessive alleles, that would be small h and small h, this is the genotype for Bombay blood group, and individuals having this genotype would have a blood group called Bombay blood group. This is a recessive genotype, which means that H antigen or H substance won't be able to express. And as we know that H antigen or H substance is the precursor for A or B antigen in an individual with Bombay blood group, even if it possesses genes for A and B antigen, it won't be able to express A or B antigen because of primary absence of H antigen. Now, talking about the blood cell present in the serum of an individual having Bombay blood group, the serum is in fact unique in itself because every serum possesses antibodies, and antibodies present in the serum of an individual having Bombay blood group, the blood group with RBCs which has no antigen, complete absence of all the antigens, that is A, B and H, would possess all the three antibodies against these three antigens, that is anti-A antibody, anti-B antibody, and most importantly anti-H antibodies. All the three antibodies would be present in the serum of an individual having Bombay blood group. Normally, physiologically, individuals having Bombay blood group do not face any problems in their life except at two instances. The first being during blood transfusion. An individual having Bombay blood group could receive blood only from an individual that is a Bombay blood group donor. This is the recipient, which is Bombay blood group individual, and this being the donor, which should compulsorily be a Bombay blood group individual too. Why so? Let us consider the blood groups from normal ABO blood grouping. Now, firstly, let this be an RBC of an individual having blood group A, which would obviously possess A antigen over its surface. If this blood is transfused to an individual having Bombay blood group, these A antigens, the anti-A antibodies present in the serum, which we have discussed, would react against these A antigen to form agglutination reaction, which would be fatal if large amount of A blood group is infused. Similarly, if blood group B is infused with antigen B over the surface of RBC, anti-B antibodies would react. And even the universal donor, considered universal donor, which is the blood group O, which lacks both A and B antigens but possesses large amount of H antigens. Why it possesses large amount of H antigens is because H antigens are considered the precursor for A and B blood group. Now, O blood group lacks both A and B, therefore H antigen need not transform into A and B blood group, and therefore the amount remains comparatively more as compared to A and B blood groups. Amount of H antigen remains more. So, coming back, if O blood group is transferred or transfused into the individual of Bombay blood group, anti-H antibodies would react, and same agglutination reaction, and if amount of infusion is more, amount of blood infused is more, the reaction would be fatal. Second complication is hemolytic disease of newborn. Now, this condition occurs when a mother, which is Bombay blood group positive, she would obviously possess anti-H antibodies in her serum. These anti-H antibodies via placenta would be transferred to the fetus. Now, by any chance, if the fetus is normal ABO type or having A blood group or B blood group or O blood group, now the same reaction of agglutination would occur, and as the number of antibodies which would pass the placenta is more, the more fatal reaction would result in hemolytic disease of newborn. This is all about Bombay blood group. Thanks for watching.